So today I want to tell you the story about space manufacturing and how it represents the future of our species. A future free from a polluted planet, one where everything in space is made in space and the prized goods on Earth are made in space too. So behold, our industrialized world. We're truly a global connected species. Every single day, 2.5 quintillion bytes of data are created. That's such an impressive number that 90% of all the world's data was created in the last 2 years. A Maasai cattle herdsman in the middle of Kenya holding a mobile phone has more access to global communication than the president did 25 years ago. And if his phone has Google on it, then he has access to more information than the US president did just 15 years ago. But there's a dark side to industrialization, one which grows worse and worse as as the standard of living grows better for us. You can see it in power plants where you can't cheat the second law of thermodynamics. For every process that creates energy, there's a heat that's created, and we're dumping that into the atmosphere and into our oceans as heat sinks. We're constantly mining our planet to get the resources we need to build the goods that are driving industrialization. Even resources that are used in solar panels, like tellurium. It's a rare earth resource, and that only exists in about a billion parts, or 1 part per billion in the Earth's crust. We see this as a trap of industrial technology. The Kariba Dam in Africa provides about 40% of the energy to the southern African region, and it's on the verge of failing. It's about to fail because low water levels and earthquakes. So now when we supplant a natural process with a mechanical one, we have to maintain it in perpetuity. But we know the answer, right? The answer is in democratization of energy and putting solar panels on the roofs of our houses, reducing the supply chain so that we can make things locally and bring industry back to our hometown, and recycling. Even to the point where we recycle our old electronics when we buy new ones. But there's problems with that solution as well. Take electronic waste, for instance. The Chinese city of Guiyu processes 1.5 million tons of electronic waste every year, mostly by children, and 80% of that electronic waste comes from overseas. So it's a horrible behind-the-scenes story of the processing that takes place on Earth to get us the industry that we have. Now, I love the planet and I love space. So I got to thinking, how can we use space exploration to change the path of industrialization that we're on? And thinking that way, I started asking myself this question: is a planetary surface really the best place for our growing and advancing industrial needs? Or perhaps is space a better place to have our these industries? And it's true, we're all in this together. We're all space explorers. It just turns out that probably I'm guessing everybody in this room has never left the spaceship. I know I haven't. I hope to one day. But we're all space explorers, and we're finally at a point in time where we can take the abundance of space and make it so that we can build a better place here on Earth. So let's look at life on board the current spaceship that we know about, the International Space Station. It's no hidden fact that we've taken a lot of technology from ISS and brought it back to Earth to make life better on Earth. And I think that's really where we begin to look at for the answer. It's the fact that the space station is a closed-loop system, just like our planet, but a much smaller one. So as we learn to develop new technologies on space station, we can bring that back to Earth. And that's the solution. The solution is space manufacturing, but more so the idea of creating new processes in the new environment of space. So a little story. This is astronaut Butch Wilmore. In the fall of 2014, he lost his wrench, in the clutter of the space station. And no kidding when you look at what it looks like there. And we 3D printed him a new one. We 3D printed Butch a ratchet on the space station. This picture of him holding his 3D printed ratchet is taken just 2 hours after we send the digital file of the part to the printer. So 2 hours later, and the astronaut's holding physical hardware in his hand. And the way we did this, probably the amazing part behind how Made in Space thought about even building a printer for the space station is that we asked a fundamentally different question than everybody else was asking. While the world has been working to build faster and cheaper and better rockets, we asked a pretty different question. What if you didn't need to launch anything at all? What if everything in space could be made there? So today I ask a new fundamentally different question. And the new question is, what if all the dirty processing and industry on Earth didn't have to happen on Earth? What if, in fact, you could bring that to space and exploit the really unique aspects of the space environment, from having controlled gravity to controlled radiation and temperature, to actually build things better in space than we build them on the planet? And it's new processes that drive new industry. So this is a really fun story. 17th century England, all the hardwood birch trees are cut down. They're cut down because it's driving the energy needs of England. And it's known that inside of water-filled mines there's coal, but there's no technology to get the water out of the mine. So England's running into a problem until this gentleman comes along, Abraham Darby, who invents the coke oven. And the coke oven allows for a new process. The process is the ability to have extremely high temperatures to create steel. The steel is used to create pumps to get the water out of the mines and get the coal. And having the coal and the use of coke ovens leads to the first industrial revolution. So Darby's process, his invention of the coke oven, leads to the Industrial Revolution. Another story, what does a laptop computer, a soda can, and the space shuttle have in common? Anyone? Aluminum. They all rely on a steady and affordable supply of aluminum. Aluminum wasn't always so cheap. It used to be so expensive. It was more expensive than gold. Emperor Napoleon III used it for plates when he had his finest guests come to visit. They all ate off aluminum while his people ate off gold. So what happened? Well, it was a new process. It was 23-year-old Charles Hall at Oberlin College in his chemistry class, whose professor said, the man who invents a way to make cheap aluminum will be very rich. Hall goes home, works with his sister, creates an electrolysis process to remove aluminum from fluoride salts, and the rest is history. Aluminum is now the most abundantly used resource on the planet, all from the invention of a new process. So I asked the question, what new process can we create in space? Or what new processes? What new processes in space can we create that remove the need to have dirty manufacturing process on the planet because it's actually more economically feasible to do it there? Could the first new industry in space be resource mining, where you could no doubt take advantage of the fact that you have controlled gravity and you could easily separate the materials to do your processing, or maybe use the concentrated radiation from the sun to to melt the toughest metals in the processing? Or is the first industry food production? Perhaps we can find a way to reduce the need to pollute our rivers and streams with pesticides by instead growing plants in space, and do that without bugs and critters on the plants, control the environment, and always have the perfect growing season. When we go to space and when we bring industry to space that benefits Earth, we will truly open the doors for people to colonize space. And it's by bringing industry to the edge of our gravity well that we bring humans, we bring life, we bring meaning, and we bring purpose. And we're a continually evolving species. That's what makes us who we are. Freeman Dyson once said in 1979, the question that will decide our destiny is not whether we shall expand into space. It is, shall we be one species or a million? A million species will not exhaust the ecological niches that are awaiting the arrival of intelligence. So I think he had a little insight into what synthetic biology looked like. But I believe that we're really there. We're on the edge to make this happen. So thank you.